Hey everyone, welcome in. Welcome to our Twitch stream. I'm Tahir Allen, and today's stream is going to be a little bit different than what we think you're used to, but trust me, I think you're going to like it. Today, we're diving into how you can actually get involved in real NASA science. And I don't mean just reading cool space facts or looking at pretty space pictures. I mean actually contributing to NASA research right from your computer or even your cell phone. I've also got a special guest joining us today. We're super excited to have Dr. Mark Kushner on the stream with us today. This is NASA's very own citizen science program officer and an astrophysicist. He's going to help walk us through some of these NASA projects that we can participate in from home and get the kicker, even right now on this stream. Hey, Mark, we're so happy to have you here today.
Hate to hear it. Thanks for having me. Thanks everyone for coming by.
Yeah, absolutely. So, folks, today we're talking about citizen science, which is really just a fancy way of saying science that's powered by everyday people like you, like me, and we've got Jared Banqui on the line right now. We've got Storm here, and we're super excited to have y'all joining us today. Now, folks, these projects are going to be all kinds of cool stuff. It's anywhere from searching for planets to weather to auroras to asteroids, literally, you name it, we have a project for everyone. And so we even have a brand new project tied to the James Webb Space Telescope that launched today. And so you heard it here first. You're going to see it here first. We're going to demo that project live today and do some classifications together. So strap in. It should be a really fun time. Now, before we get to that first project demo, we want to know what else you'd like to explore today. So you can kind of think of it as a choose your own adventure game. So, do you want to learn how to search for new planets in our solar system? That's going to be with Backyard Worlds Planet 9. Do you want to discover near Earth asteroids, which are asteroids that enter Earth's neighborhood with the Daler Minor Planet Project? Or do you want to go cloud hunting on Mars with, you might have guessed it, cloud spotting on Mars? So go ahead and vote in the poll right now in the chat. Now, while y'all drop those votes in, Mark, do you have any guesses on who you think's going to win the poll today?
Oh my gosh. Well, everyone wants to discover an asteroid, and Daily Minor Planet Project, 4 volunteers now have asteroids named after them because they discovered them in this project. On the other hand, Mars is really hot right now. Should I say cold? And you can find water ice and carbon dioxide ice in its atmosphere on cloud spotting. Or, geez, I don't know. Maybe it would be cool to find 9. I mean, how many planets do we have in our solar system? Is it 8, 9, 10, 11? So Backyard World's Planet 9, you might get the jackpot and be the next Clyde Tombaugh discovering a planet. So that's a rough choice.
Well, Mark, I think everybody's going for the jackpot. They're going for the win today. And it looks like on the Twitch stream, we've got searching for planets currently winning, but we got some time for the poll to still stay open. So folks, as you can already tell, today is an interactive stream. We want to hear from you. We're going to be talking back and forth throughout the next hour. So if you've got some questions for Dr. Mark right here, drop them in the chat at any time. I'll be monitoring the chat to keep an eye on the stream, and we'll answer them live on air. Now, I've also got some really awesome mod friends in the chat who are helping me out behind the scenes, so be sure to look out for NASA Red Crew. We are, if we have not stated it enough, super excited to be here. Again, this is a totally fresh way of doing things. We're really excited to have this interactive stream and be talking about these incredible opportunities. Now, while y'all are still voting, we're going to walk through the newest project that launched today called Galaxy Zoo, where you can classify tens of thousands of galaxies from the James Webb Space Telescope mission, arguably a fan favorite. Now, Mark, can you share your screen and show us how folks can participate? And at the same time, can my NASA Red Crew friends go ahead and drop the project link in chat for folks so that way you can follow along in real time if you want? All right, sweet. We've got the project up. Mark, what's the first step here? How do we get involved? Well, actually, first, what are we working with?
Yeah, what are we working with? So this project, yeah, it's hot off the presses. It launched this morning, and there's already hundreds of people online chatting about it and working on it together. That's so fun to watch. So Galaxy Zoo project has been around looking at different data sets since around 2007. And this has been such a scientific powerhouse. I mean, Galaxy Zoo Project has produced more than 450 scientific publications through those years. And now it's supercharged with data from the James Webb Space Telescope. And this data, as you know, brings the power of this telescope, which can look farther away and hence farther back in time than previous telescopes. So, when we do this project, we're going to be looking at images from James Webb Space Telescope of galaxies. Sometimes other stuff gets in there too, but mostly galaxies. And we're going to be classifying them to try to make sense of what they are and how they formed and what they mean about today's galaxies. And we may be looking at images that nobody else has ever seen before. That's super fun.
That's crazy. Mark, how's that even possible? You know, you would think that a science team has to see it, or is there just so much data that's coming down? How could we be the first people seeing these images from Webb?
Today's space telescopes produce data at such a terrific rate that we need help from everyone we can we can ask to make sense of it. So although the science team, so lots of people work to process the data, they haven't really had a time to study it, to break it into the little kind of postage stamps and zoom in on each galaxy that's been custom processed. And that's where we really need people's help. Really, really staring at these things and thinking about them.
Well,
Shall
cool.
we?
We're on the project page. Where should somebody get started? Well, I guess
Okay.
other than get started.
So yeah, so super easy way to find this project: galaxyzoo.org, and then you show up on this page, and you can always click the Learn More button to read about the scientific background. There's lots of info here
Okay.
about the survey and telescope, but let's just go click Get Started and dive right in. So if you didn't have me
Yeah.
here yapping at you, there'd be a tutorial which you could follow, which gives you some instructions on what you're going to look for, and just kind of click through that. And the point is that we're going to zoom in. We're going to focus on whatever is in the center of the image, and we're going to try to make sense of it. Ooh, this is an interesting one. We've got two different
So, what are we
views,
looking at?
different views of the same object. So I may actually take that tutorial again, see if it's got some more info for us. Okay. Yeah, I think these are just two different scalings. Oh, two different scalings of the same object. So a scaling is like a process, it's the same data, but it's processed in a different way to highlight different features about it. Right. And
So, we know we're looking at a galaxy.
we're looking at a
Perfect.
galaxy, and we're just going to read this question on the right, and it's got some little cartoons for us, and just try to answer the question best we can. Is the central galaxy simply smooth and rounded with no sign of a disk? Here's a little picture of the smooth option. And here's some
This
examples
one's
of
kind of
galaxies.
tough.
And sometimes you'll get a star that gets in there, and then the star will have often 6 spikes because of the hexagonal symmetry of the James Webb Space Telescope mirror. So what do you think? Do you see sign of a disk? I don't see the spikes to here. Do you see spikes?
I'm I'm gonna go smooth. I'm also gonna toss the question to our
Yeah.
Twitch streamers right now. If you're watching and you want to participate, do you think it's smooth? Do you think it features a disc, or does it feature one of these um, other signals right here listed. And while we give folks to a time to chime in, Mark, I've got a question for you. We have a
Yeah.
ton of people in the chat who want to know if Dr. Mark has recommendations for a backyard telescope.
Oh, that's a cool one. Well, of course, there's so many good ones on the market these days. You can get telescopes that um, will connect to an app and automatically point to an object of your choice. And those are great options for people who
Wow.
are new to backyard telescopes. We have this great partnership with a team called Unite that does a citizen
Hmm.
science project around one of those telescopes called an EV scope. There's also a less expensive version of that, sort of from a different company that's called Sea Star, like SEESTAR. Um, and new ones are coming out all the time. So I may even be out of date.
Cool. Thanks, Mark. Now, the votes have
Sure.
come in. Most people are saying smooth. So let's smash that smooth button.
Okay. Smooth it is. Bam. All right. Next, it's going to ask us some more questions. All right. Is the galaxy merging or disturbed or not? It could be not disturbed, right? So, galaxies, our galaxy, they're crashing together all the time. And that's where we think big galaxies like ours come from, is that they used to be small galaxies and they crashed together. So, as we look at other galaxies far back in time, which we're doing right now with these James Webb images, right? We're looking at the galaxies that probably smashed together to form the big things that we live in now. And um, so, galaxy mergers, galaxies collisions are a huge part of the story of the formation of our galaxy and the history of the universe. So, very important question. So, we look at this object. Do we see any signs of a recent crash or um, um, one of these cataclysms happen? Sometimes there'll be this spray of stars that'll kind of just getting lost into intergalactic space that you'll see, um, and or maybe sometimes just a minor disturbance to the shape of it. Do you see any signs of these collisions going on? What do
Mark,
you
can you
think?
scroll up a little bit? I've got folks telling me that we can't see the fourth option.
How about
Now,
that?
okay, the fourth option is none to everybody
None.
on the stream, but we
Yeah.
also have Reality Ripple and a few others saying undisturbed. Um, Folks, now that we can see the fourth option,
That
do we want to
not
go with undisturbed?
that makes sense to me. I'm
Minor,
seeing lots of
major.
noise. See all those kind of pixels? Looks like Minecraft or something in the background, right? That's just noise from the telescope. Um,
Oh, Mark, somebody wants to know. We have Chill Mute who wants to know what are the two dots on the bottom middle? That's a good point.
Two
Are
dots.
those? Are we able to switch through photos?
Why? Thank you. Yeah.
Oh,
So here we
whoa!
have.
Thanks, Chill Miner.
Yeah. Great. So one special feature of James Webb Space Telescope is that it has the ability to detect different wavelengths of light, right? And of course, with our eyes, we combine different wavelengths together and we perceive color. But these different wavelengths tend to be in the near infrared. So there are lots of different ways you can, try to combine these together or interpret them in terms of color, but nothing is going to correspond exactly to the way humans perceive color. So here they're offering us a chance to view different wavelengths one at a time and see if they offer us any other clues. Hey, that was a great catch there. Does this give us any other clues about whether there's a merger here or not? I think I'm kind of leaning towards it.
I
Come
Yeah, I think I'm seeing a lot of people say
on.
none in the chat. Let's go with none.
None. Okay. Oh boy. Okay, lots of options here. Okay. Is there a ring? Is there a lens or an arc? Often you'll see a a heavy object in space that's in front of another galaxy. So, say you had a clump of dark matter or a black hole or something that's in front of a background galaxy. And because gravity changes the path that light takes, it'll act as a lens and it'll change the apparent shape of the object. It'll tend to make it into these kind of Einstein rings, or you'll see multiple copies of it, stuff like that. That's what a lens is. Those are awesome if you spot one of those. We have irregular objects, dust lanes. So the Milky Way has all of its dust in the midplane that obscures stars. Um, Sometimes you'll have overlapping objects. There'll be a foreground galaxy, a background
Mark, let me
galaxy.
ask you real quick. One, we've got Sandus on Twitch who wants to know if we can switch to the other dot again to get that second type of view. And then we also have a really good question from B. Gibbs who wants to know, what galaxy is this? Or are we trying to figure that out? Do we know which
Yeah,
one it is, or is this just one of those like
great
early
question.
galaxies that Webb is able to see?
I'm gonna click. Okay, okay. So I didn't have the details. So um, not every galaxy is in a catalog just yet, and many of these galaxies that we're looking at in Galaxy Zoo are not yet, named or cataloged.
Mm-hmm.
It's a great question. So there are more galaxies in the sky than there are stars. So it's a big project to keep track of them all.
Okay.
Do you see,
Well,
do you
right
see
now
any of
I'm
these?
seeing people are saying they're seeing a bit of a disturbance.
Oh,
Um, is
disturbance.
that
Of
an
course.
option?
Like this kind of thing here, maybe. Yeah, I this structure here
Yeah, that's
is catching my
questionable.
eye. Yeah, especially since it appears in multiple different visualizations. Yeah, multiple different thingies here. Does that correspond? Does that would we call that irregular or maybe something else? I'm kind of feeling something else, but what are you guys thinking?
I'm checking the chat.
It's hard to tell. Um,
It is hard to tell.
and hey, welcome to science, right? If we knew the
Ah, we've got
answers,
we've
it
got a
wouldn't
helper
be
in the
science.
chat too, Mark. We've
Yeah.
got a helper in the chat. Astro Haley reminded us to check the field guide.
Oh, let's
We
check
haven't
the
talked
field
about the
guide. So
field
we have
guide yet.
on the right of every project that you'll find on zooniverse.org, there's this handy tab labeled Field Guide, which has examples of things. Ooh, yeah.
I think this one is still a little difficult.
It's still
Mark, let's
difficult.
go
It's
with
kind of
something
like
else right now.
yeah, I think I agree with
Yeah,
that.
let's go
That
with something else.
guesstimate there.
Okay.
Okay, now we got a new one. Hey, we
Mark, are the
moved on to
pictures
another
usually
galaxy.
this pixelated, or do we never know what we're going to get? Like, could we get some that are a little clearer? Um, what
It's
do you,
a it's a
yeah, what do
it's
we
a
expect
game
of the
of roulette.
project?
You never know what the slot
Yeah.
machine will bring. So sometimes they're spectacular and clean, and sometimes you're digging
Mm-hmm.
deep in the noise to find those faint objects. One exciting thing about looking at a noisy object like this probably means the galaxy is faint, which often means that it's very far away. So this is what it's like to look back in time with James
Back in
Webb.
time.
See
Wow, that's crazy.
galaxies that are really faint like this. Something I want to point out um, is that there's a button on here called Done and Talk. So we hit the Done button before, but if you hit Done and Talk on Zooniverse, it takes you to a new world. So in Talk in Zooniverse, there's another way to get there, so I'll take you there. It's a bulletin board, and the bulletin board you can interact with everyone else who's looking at these galaxies. So, for example, here's Karen Masters, the lead
So
scientist
it's like
on
a
the
chat
project.
room.
the chat room, right? So we could
Cool.
ask Karen, we could ask um, other colleagues, we could ask other folks who work on the project what they think. And so maybe, do we have time to keep digging on this one?
I think we need to keep it rolling because our poll votes
Okay.
are in, and I am very excited to share it. So, right now, though, it looks like we've got a bunch of folks saying disc. So, let's go with disc.
Disc. Ooh, I'm here for disc. I live in a disc. Okay. Is it edge on or is it something else? We look at some of the other views here.
That's tough.
Oh, we're really digging deep into the noise on this one.
Yeah, we are.
Yeah. Should we say something else or
The people are saying edge on.
that's another cool way to view the data. See this little kind of half
Oh,
moon
that
shape
is.
here? We
Yeah.
can flip the color scale. It's kind of nice flip like that.
Okay, sweet. Let's go with edge on.
Edge on disk. All
Mark
right, next.
Mark Robert
Mhm.
Tables wants to know what eventually will be done with these classifications. Like we're answering all
Yeah,
these questions, but
yeah,
then what does that correlate into?
sure. Great question, Robert. So, science team will look at the classifications. First thing you want to know is that um, multiple people will look at the same object. So, don't ever worry about making a mistake on Galaxy Zoo because there are lots of different ways that your input will get checked. So, multiple different citizen scientists will view the same object, and those votes will be aggregated into a classification. And then the science team will look at the results and argue with each other about what they mean. And then they'll write up a paper and they'll go back and forth with an independent, anonymous referee uh, before that paper is published. So the next step is a lot of people examining the data, with you essentially. Then one the, there are people on the Galaxy Zoo team who have different interests. They probably have different pet galaxies, different trends that they're interested in following up on. Some folks on the team are interested in galaxies with bars. Some people want to know about the merger history and I've even seen a paper in the literature already uh, related to this project with initial results about the smoothness of galaxies. The teams are already reporting that they are finding that the galaxies in this population are especially smooth, and it may have something to do with the increased abundance of gas as you look back in time. So galaxies, as they crash into each other, they often leave their gas behind in the intergalactic medium, and it's
So Mark,
part of our
right
galaxy.
now, we've got a bunch of questions from folks wondering what the sidebar, Sandus wants to know, what does the
Yeah,
sidebar under the left picture do?
great question. Sidebar. Oh, okay. So this will play.
And can you scroll
Oops.
up a little bit? Our our heads are blocking it.
Think so.
Yeah, that's good. Or maybe a little, yeah, that's good.
So this this exact project and this exact galaxy, some Zooniverse projects have multiple. In fact, if we look at one of either Backyard Worlds or Daily Minor Planet, it's possible these projects show little movies, and so you can control the speed of the movie with that bar.
Okay, awesome. Thanks, Mark. So
Sure.
we probably need to wrap this task up soon so we can get to the second tutorial. I'm seeing a bunch of folks in chat say that this looks rounded, so let's go with that.
Rounded. Okay, interesting. So you're seeing a bulge in the center of it.
It does look a little darker in the center.
A little bulge there. Okay. Huh. I'm not seeing it, but let's go with rounded. Actually feels a little boxy to me. Does it feel kind of square on the edges? But that may be an artifact of the pixelization. Wow, aren't you glad you don't have to program a computer to try to make these calls?
Yeah.
Yeah. Okay, so are there any obvious bright clumps? Now remember, we're focusing on the object in the center, so we're going to ignore that clumpy thing, whatever that is down there. Do you see any clumps in here? Huh, what's this little thing over here that's in multiple images? When I see it pop up at different multiple wavelengths, it makes me think there might be something to it. What do you guys think? Slightly clumpy?
I think
It's
we're
really
going
hard
to
to
go
call.
with no bright clumps.
No
And
bright
Mark, so
clumps.
you showed us the talk option. How do
Hmm.
we wrap up a project like this?
Yeah. So the next question, we're familiar with this one. Um, so it's when whenever we got done classifying this one, we'd have that option to go to talk and join the conversation, or just start looking at other objects. And these, um, you can really dive deep into some of these projects. So when you go into talk, for example, and you have conversations with people who are working on it, often volunteers will form these groups, discussion groups, around their favorite objects or trends that they're seeing. So, for example, back soon after the original version of Galaxy Zoo was launched, a group of participants got together and they were seeing these objects, these kind of round green colored galaxies, and they started calling them green pea galaxies. And they got together and they wrote a paper themselves about the green pea galaxies, which has gone down in the history of
Wow.
galaxy research. So, um, you, every one of
So
these
it's so
projects is a
cool,
rabbit
Mark.
hole. It's a rabbit hole.
And it's so awesome how you just mentioned how just everyday people can join together, classify objects, and then publish their own papers. So, you just showed us Galaxy Zoo, but for everyone watching, we have over 30 different projects. Like I mentioned earlier, where if you are interested in auroras, if you're interested in clouds on this planet and others, asteroids, you name it, we have it. So, Mark, would you mind actually sharing your screen to show all the projects that we have to offer? And maybe
Sure.
let's talk a little bit about those before I reveal the poll.
Awesome. It's like the price is right here.
It is. You'll see what's
Yep.
behind that door.
It's behind
What's
door
so
number
fun,
3.
everybody watching, is that Mark has no clue what project has won. I'm able to see the chat, but this is going to be as much of a surprise for him as it is for, well, actually, he's going to be the only one surprised. So this will be fun.
Oh, geez. Okay.
It's good. We'll be nice.
Playing
Um,
surprise the
yeah,
astronomer. Okay, all right, fine. So here's
yeah.
Daily Minor Planet. This is where we look for asteroids, especially near Earth asteroids. Keep going.
Mark, do you have the main citizen project page, like our
Sure.
science.nasa.gov/citizen science, where we can just show them the whole menu
Oh,
of
yeah.
projects? The whole
34
menu.
different projects.
Awesome. So while
Uh,
you're scrolling through this, what kind of equipment do people need to participate in these projects? Folks were asking about, do they need telescopes? Do you need anything special to be able to, make a mark like this on this science?
Great question. So the projects that are here at the top of the page are for anyone with a smartphone or laptop. So you can do Galaxy Zoo on your screen. You can do it on a little screen like this, right?
On the go.
Um, right. And so
Yeah.
we also have projects for people who really want to go wild. We have more specialized projects. So if you have your own telescope, you can join a project like Exoplanet Watch or Unite, and those are both projects that ask amateur astronomers to study uh, extrasolar planets. exoplanets, so planets that are orbiting other stars. And you can do important research on those objects with a backyard telescope. And those teams do some fantastic stuff. There are also
Mark, do people
projects
need to
for,
have a science background to do these projects with NASA?
oh, no, 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 no. All these projects, uh, all these projects teach you what you need to do. So we just saw in Galaxy Zoo, for example, there's that nice tutorial and field guide, everything you need to know. You can also ask other people for help. There's also, by the way, I didn't show you, there's yet another help feature on here. There's the need some help with this task button. So you can go here, say I needed help deciding if there was a major disturbance. Got these great examples.
Oh,
Objects right
that
there.
is actually a
That
really
would have
great
helped us
task.
out a second ago.
That would have helped.
Yeah.
We
Um,
know this now, though. Need some help
yeah,
with
lots
this
of nooks and
task if
crannies.
you're stuck.
So yeah, so most of
Okay,
these projects
cool.
are set up so that you don't need any background knowledge. One of the probably the easiest project is a project called Mountain Rain or Snow. So Mountain Rain or Snow sends you a text. You sign up, and it sends you a text to your cell phone, and um, asks you, "Is it raining or snowing?"
And all you do
And
is say,
you say, "Yeah, it's raining," or "Yeah, it's snowing," and that's it. But that's incredibly helpful because we have the best weather satellites in the world, and they can't always tell exactly what's going on the ground. So they could spot the clouds, the radar reflectance of the weather system, but they can't necessarily translate that into exactly what is landing on your windshield right now. So it's a big help to have that additional information if we want to learn how to better predict the weather and understand the climate.
so, Mark, before we reveal the poll, reveal what's behind the door.
Okay.
You kind of hit on this with talking about the projects, but what science areas can people do NASA science in through these projects? Like we've talked about Galaxy Zoo, so we can do things with astrophysics, right, in the cosmos. But what else can we do through these project offerings? What science areas you'd say?
Sure. So there are citizen science projects in every corner of NASA science. So we do astrophysics, heliophysics, planetary science, earth science, and biological and physical sciences, which is experiments that are done in the environment of space. And that spans an enormous range of things. I mean, we have projects on asteroids, as you saw. We have projects on um, this is a project on phytoplankton, right? This is on ice thickness in Alaska. These are folks who are testing seeds to see whether they'll grow, whether they'll be good food for astronauts. We have ham radio operators who are studying the ionosphere. People are studying the depth of water in lakes, which is surprisingly unknown. There's the Mountain Rain or Snow project I talked about. Radio Jove, people are building their own radio
Wow.
telescopes and studying Jupiter and the sun. Spritacular. I didn't even know about this until this project appeared online, but there are these things that appear above thunderstorms called sprites, which are kind of like the up version of lightning. All right. And that's what
That is so
these.
cool.
So, you name it, we've got a fun project around it.
There really is something for everyone. So, folks, really encourage you to check out this page. Our awesome moderators in the chat, NASA Red Crew, will drop a link. Be sure to go and find the perfect project fit for you. Now, it is time to reveal the poll, Mark. Drum roll,
Okay.
please. And with a 65% of the vote, we have searching for new planets in our solar system has won the poll. So, Mark, can you please share your screen and let's hop into the Backyard Worlds project, which I'm super excited that folks chose because, Mark, aren't you a scientist on this project? Like, this is you're very close to this project.
Yeah. So before I came to headquarters to help with the program in general, I spent 15 years being just regular old astrophysicist at Goddard Space Flight Center, and one project that I had the pleasure of starting with some fantastic colleagues was this one called Backyard Worlds Planet Nine. So
You started
Jackie
this
Parody and
project.
Adam Schneider and um, Aaron Meisner, and now Davey Kirkpatrick. We all run this project, and it's been just so addictive. Like I can't
Yeah.
describe it any other way. We really can't get enough of working with the team, and this project has discovered uh, more than 4,000 of these objects called brown dwarfs. So let me tell you more about the background. So surprisingly little about what's going on beyond uh, of Neptune, right? So we only recently figured out that Pluto is probably not best classified as a planet because there's lots of other objects out there that resemble Pluto. Uh, but what we're doing is we're perpetually repeating, in some ways, the experiment that Clyde Tombaugh did to discover Pluto. So he would look at an image of the sky taken on one day, another image of it taken a few days later, and he would blink back and forth to search for moving objects. And amazingly enough, do you see the end of this little arrow there? Was a little dot, and somehow he recognized that that dot had moved over here in the next shot.
So it's like spot the
So
difference in the photos. It's like a game, right? That people
mhm,
are used to.
mhm,
Cool.
mhm. So, um, yeah, so Clyde Taubaugh found Pluto that way, and we are going to look for other objects that using the same system, but instead of visible light, we're going to use infrared light. So we'll be sensitive to objects that are, emitting their own thermal radiation, right? And um, so one example of an object that we could find is the hypothetical object called Planet Nine. And Planet Nine, the hypothesis comes from this, which is that there are a whole bunch of objects out there that sort of resemble Pluto, and their orbits have patterns in them. They There are correlations among their orbits, which make it look like they've been shepherded by some kind of massive object that has maybe 6 times the mass of planet Earth, would nicely explain the patterns that we see in the orbits of these other objects called Kuiper belt objects. So we're out there looking for this possible perturber, right? Planet Nine, it would be if we just count in
Hmm.
order. Uh, but we're also sensitive, besides this particular hypothesis about Planet Nine, we're also sensitive to an analog of Saturn out to 28,000 astronomical units, beyond 28,000 astronomical units. So we might see planet 10, 11, 12, right? If we in the right place at the right time. Um,
Mark, I've
Beyond
got a
that,
quick question actually. Got a quick
yeah,
question from our viewers. Hassan View wants to know, can people use this, like projects like this, to get into astrophysics as a beginner?
of course you can, Hassan. We'd love it um, if we caught your imagination and we serve to inspire you to pursue deeper studies in astronomy, astrophysics. That would be a big win for us. So um, I sure hope
And Mark,
so.
some of these
And we've
people,
had.
some of sorry,
Go
I
ahead,
think we
Gina.
were on the same, I was going to ask the same question. Like, aren't, I believe just from working with you, I've heard that, some people that do discover some of these uh, objects in space don't come from an astrophysics background or a scientific background, but it's through these projects they were connected with project scientists or astrophysics communities. And it really kind of was a door into this world.
Exactly, Tahira. And now more than 500 of our participants have become co authors on published scientific papers through their work on NASA citizen science projects. We do our best to post them all on this webpage. I'm going to show you now. Oops, where to go? And there we go. So here we have more than
Wow,
500
awesome.
participants, co-authors on papers, and that just delights me to no end.
Wow, awesome. Somebody on this stream may be next. So be sure to check out the projects. And so, Mark, with that, folks are super jazzed about this idea about finding Planet Nine. Let's get started in one of these
Um,
tasks. How do we,
let's
go
get
about
into it.
this?
Let's do it.
Let's get into it. And while you're pulling up the task, we have Cobalt Ethan who asks, is the hunt for Planet Nine a radar based approach? Is a
Oh, that's a
radar
great question.
based approach not more practical than an infrared picture based attempt for detection?
Oh, that's a really great question. Yeah, so radar has taught us a lot about the solar system. It's great for interrogating the moon, interrogating near Earth asteroids. Right? If you have enough power, you can bounce a signal off of one of these objects and really learn quite precisely what its orbit is. So the trouble with finding Planet Nine is that we wouldn't know quite where to point the outgoing beam, right? Uh, so
Oh,
Planet
that's
Nine
right.
could be anywhere in a pretty big donut kind of space, and you'd be scanning all day. So instead of doing that, we try to collect light from the object, and people are searching for it in infrared
Hmm.
radiation, and we're searching for it in visible radiation. And this particular search is an infrared search. So it wins in the case where the planet is especially good at absorbing light or is especially massive. Uh, so um, so we try all these different
Okay.
techniques.
All right, sweet.
Um,
Let's
did
see
I
if we
mention
find
brown
it
dwarfs? You
on
never
this
wanted to talk
stream.
about brown dwarfs. Yeah. So brown dwarf is what happens if you have a ball of gas and it's not big enough to sustain nuclear fusion in its center. So, the sun burns because it's steadily combining hydrogen nuclei into helium nuclei. But in order to do that, you certainly need certain pressure, right? And if your ball of gas isn't big enough, then it might start some nuclear reaction or other, but it kind of peters out, and you don't end up with a star. You end up with a
Mm.
brown dwarf. Wait a minute. You should be saying, that sounds a lot like Jupiter. Jupiter is a ball of gas. It's
Hmm.
it's not massive enough to be a star. You would be right. So gas giant planets and brown dwarfs, they're kind of two ends of the same thing, right? If you had Jupiter and it was around another, and it was out there on its own without a star, you might consider it a brown dwarf. And likewise, we often have trouble figuring out when we see a planet candidate around a star, is that a planet or is that a brown dwarf? The two populations overlap. So Backyard World's Planet Nine
Let's,
uh, has
yes.
not yet discovered Planet Nine, or you would have heard about it. It would have been on the front page of every paper, but it has found more than 4,000 brown dwarfs, including entire new categories of brown dwarfs that nobody knew existed before. And this
Well,
was a
hopefully
bonus.
we find one today.
Okay, to hear this jump
Do you
down.
think
All
we
right,
will?
we're gonna do it.
I know, I'm
Let's
biting
do
at the bit.
it. Okay, I'm gonna mash the join in button, and we're gonna dive in and see what we discover. Oops, and I messed up somehow. We're going to mash the get started button, as I was saying, and get going. Okay, so here, remember we were talking about how there's this little bar down here and the play button. So this time I'm going to hit the play button and see what happens, because we have a bunch of frames. Remember I talked about how Clyde Tombaugh was studying pictures
Hmm.
taken at different times. That's what we're doing here. We got 4 different shots of the same chunk of sky, and here we can play them over and over again. And I'll just keep this playing. In fact, if I crank up the speed, does that make you guys happy over there in Twitch land? I
So,
know it's
Mark,
not
in the
quite like first
tutorial,
person
what are
shooter,
we
but
looking for?
yeah. Okay, so as you can see, there's a whole lot of noise on there, and that's what happens when you stare into
Hmm.
deep space uh, you get a lot there's a lot of noise you have to go through. But there are also some objects that are clearly not noise, and that is what we're looking at. That's what we're looking for. We are looking for things that we refer to as movers or dipoles. And let's look at the examples in the field guide. So this is a dipole for you. See, it flips back and forth. It's dark on one side, it's light on the other side. They have these great cookies in New York City. They're like chocolate on one side, vanilla
Mm.
on the other side. That's
Oh,
what these things
yeah.
remind me of. If we had one of those that flip back and forth, it would be a dipole. And then that's an object. If you see that, you're looking at an object that's moving across the sky at kind of moderate speed. If you find something that we call a mover, then you're extra lucky because now you're looking at an object that's really whipping across space. Here's an example of a really bright mover. This one happens to be red color because it's cool. Extra points for kind of cool objects. I'm talking about in temperature cool. So this object is close to room
Hmm.
temperature. And the dipole we looked at before is probably hot. It's probably 5 or 6 times room temperature, maybe. But here we have an object. A mover marches across the screen in a straight line. So both the dipole and the mover, they're going in a straight line. So if you see something that's kind of like it's like twisting, or it's expanding and contracting, or if it's changing shape, it's probably not one of these objects. All right, so is everybody kind of prepped? Everybody tuned to look for movers and dipoles?
Everybody's equipped. We've got Steph R LRX who wants to know what is a dipole.
Yeah. Well, let's see if we can find one in this image.
Was that your cookie
Um,
reference?
that's the cookie reference, right? So it's something
Okay,
that's
because
dark
I
on one
feel
side,
like I
light on the other
see
side,
one.
and it's flipping back.
I
Ooh, you
feel
see one. So this
I
project has got labels on the axes. So if you see one, you could call out the coordinates where you see it.
okay,
And these are actually
at
coordinates on the
about
sky.
3.50 and
2.50.
a
Let's
little
set up to
above 45.12.
minus 45.12. Is that this sucker you're talking about?
Yeah, is the light flipping white and black? Or am I
Hmm.
making that up? What do y'all think in the chat?
W's in the chat.
Yeah, 350 top white, top right cookie in space.
Top right cookie in space.
What do you think?
Yeah.
What do you think, Mark?
Um. Yeah. It's definitely flipping back and forth for me. It's not super clean. Like there's some sort of like weird kind of noise or distortion to the shape over here. But
Okay,
yeah,
we've got other
it's
folks asking
flipping.
about E14. Is that
E
selling you on a
14.
dipole?
Any chance? Let's see. What does E14 mean? Can I
Oh,
get like a?
E14, maybe that.
This number is called the right ascension. This number is called the declination. I get a right ascension number and a declination number.
3.42 negative 45.22.
3.2 negative 45 degrees.
Yeah, folks are thinking something around that.
Over here.
45.15.
Yeah, there's definitely something going on there. Also, that's kind of
Mm,
complicated. Um,
yeah, it is.
it,
So, Mark, if we need to
aerial.
move on past this task, like, should folks make um, a pointer on a dipole if they are not sure, or is is this a project where if we make a marker, even if we're on the fence, it doesn't mess up the data?
Yeah. Oh, no, you don't have to worry about messing up data in these projects in general, right? Because lots of people will weigh in. Um, don't be afraid of that. Um,
Okay.
I think this one is worth calling attention to. Um, I clicked
Okay.
it.
And
Got to
can
click
you
it.
scroll up a
Generally
little
got
bit? Folks can't see the bottom right now.
I
Okay,
slowed it
yeah,
way
that's
down so
good.
I can more easily click it in every frame.
Okay, everyone, we
Okay,
have one.
got the heck out of that. Yeah, and then you know what? There's a bunch more on here. So I want to call this thing to your attention.
Okay.
Yeah. See, it's faint, but look how it flips back and forth. I'm gonna mark that sucker up.
Mark, we've got
And
folks wanting to know if you look in the bottom right
ah,
corner,
bottom right.
around 4520, what's that big kind of splash of light? You're going to
This
see it
thing.
right
Okay.
there. Yeah.
Yeah. Okay. You know what? You know what we can do? We can. There's a couple ways we can find out more information about this particular image. So this project. Remember how I said these projects are rabbit holes? See this little eye in a circle? If I
Yeah.
mash the eye in a
Information.
circle, yeah, it's going to take me to a bunch of links. Let's go to the Wise View link. So Wise View is a tool written by a citizen scientist um, that's going to show me a different view of the same data and might have
Oh,
some
whoa.
more information for us.
Oh, my goodness.
Oh,
Is this available for every
here it
project?
is. Well, every project's different. I mean, lots of projects
Wow.
have other links in them, but this is unique to this project. So now we can see what's going on pretty clearly right now. Okay, so what
Is
we
it a
have here,
supernova?
this no, this is just a bright
No.
star. So these are
I
diffraction
tried
spikes.
Nostradeva.
Yeah. Um. So stars are fascinating, of course. This project, most of the objects that are bright enough to have diffraction spikes in this project are things that are already known. The prizes in this project are faint. They're often red. So we're really trying to
Mm.
find things that have not yet been discovered here. So I wouldn't get too excited about this one because I'm pretty sure that it's already in the literature. It's nice to spot it again, comfort ourselves, right? But if you want to discover your own thing, you want to dig uh, deeper and look for objects that are fainter. So where was the object that we saw that we've been clicking on here? So you think we can find this in the Wise View image? That's somewhere around here, isn't
It
it?
was, yeah, it was somewhere around there.
Yeah. Ooh, it's kind of a triple of objects. You see how in this view it's a lot harder to spot moving things? It's the same
Yeah.
data, just visualized a different way, right? And here, this view um, really hones in on it, really emphasizes objects that are moving. They really stand out.
And Mark, you
And
got to that view
in this
by clicking the little I button, right? Can you show us that one more
little
time?
eye,
Folks are
sure,
wondering how they can get to that.
great. The little eye in the circle. You see the little eye in the circle?
Mm-hmm.
And each one of these links will tell you more information about what's going on in this scene. You can research your favorite object. You can often find out that your object doesn't have any information on it, which is great. That's actually, we love that, right? Um,
Yeah.
yeah. Um, in fact, if you research your favorite object in this uh, database called Simbad, and your object that you've clicked on is not in Simbad, then we really want you to report it. This is kind of advanced. This is the next level stuff. If your object is not in Simbad, then we'd love it if you would report it by using the Think You've Got One form. Can I show you the Think You've Got One form?
Yeah. Let's do it, Mark.
All right. If you found something interesting and want to learn, if you found something interesting and you want to learn more about it, see the FAQ. Always read the FAQ. Here in the FAQ, you will find the think. Oh, here's the black and white cookie. You will
So this is
find
what we use if we think we found something new, right?
If I think I discovered something, it's great to mark it on the
Hmm.
talk page, but please fill out this form. And here's a form, and you can send us. What'll happen is that if you click on things, we will find out. Every few months, we'll go through the click data and sort through it. If you fill out the think you've got one form, we'll find out faster. Plus, it's going to ask you for more information that will help us make sense of it sooner. So if you think that you've got something that's important and you really want to get a quick answer on it, it's still not quick like compared to like a video game. Sorry, but it's faster, and you can fill out this form, and the science team will find out faster whether you have a real
And you
object
can
with you.
make a difference, which is so cool here, Mark. I've got about time for one more question, and I have Charya, who asks, "How can we, as citizen scientists, get co-authored in research papers?" So, can you give us a quick answer to that one?
Yeah, um, there's no one way. Um, the yeah, each project is different, but each one of the projects that we looked at has some way of engaging in a conversation. So I would do some of the classifications, follow the instructions as best you can, and then go into the talk boards and have a conversation with the science team. And if there is a form like the Think You've Got One form, definitely take advantage of that. Daily Minor Planet has a form like that. See, be sure to fill out this form here. So fill out the forms and let the science team know that you're serious. And as side projects come up, you'll hear about them. And here's the thing: it's not planned in advance. This is science, right? It's a roller coaster ride.
Yeah,
It's full of there's dead ends, there's stuff that doesn't go as you planned, there's bad weather, there's a hypothesis that turns out to be a huge waste of time for everybody. There's you know it's it can be rough, but there's also these moments of just total ecstasy when you find out that when you get surprised by a result, when you discover something totally new, and nothing beats that feeling.
absolutely. This is so great, Mark. Thank you for walking us through the citizen science projects today. I mean, as you just mentioned, people really have an opportunity here to not only contribute to science, to really make their own discoveries, to find something in this huge cosmos that is uniquely theirs for one moment until it goes into the science community. But I just think that
Yeah.
is such an amazing thing that you're really cultivating at NASA. And we're so appreciative that you were able to jump on this stream and really show us how anybody can get involved in these projects. So thank you for joining us.
Thank you. And I hope to see you all online in one of these talk boards.
Yeah, absolutely. Thanks, Mark. And thanks too for everybody that participated in this stream. This was amazing. It was actually so fun too, as somebody that is just doing this with y'all. And I hope you are inspired to go find your own citizen science projects, contribute your own discoveries and data. As Mark mentioned, we have so much data, and we it really takes all of us to help really advance humanity's knowledge forward. So these were just two of the many citizen science projects that you can get involved in and participate in at any time, many of them from anywhere, from a computer or a phone. And so visit science.nasa.gov/citizen science to see all of the projects again that we went over today. You can also join the global community of volunteers by following Do NASA Science on X and Facebook. Head on over there. You can share stories, you can share findings, and you can really learn from other people doing NASA science. We are just so excited that you joined us today and really look forward to all the discoveries you will make. Thank you, and see you next time.